everything that's in that section. Today's video, where we're going to be going through the lecture guide for Module 0. So this module is based on Chapter P, mostly focused on P.1 and P.3, although there is a little bit from P2, so you can check that section out in the book for more information, although I won't be holding you to everything that's in that section. So the way these lecture guides will work is I'll start off with the learning outcomes for the module, just so you can see what I'm expecting of you, the vocabulary words, what types of problems I'm expecting you to be able to solve, just how I want you to be able to put things together. So in this video, I'm not going to be going through every one of these vocabulary words. What I want you to do is go through these yourself, go look at the terms, try to see if you can get a feel for them. One thing you might want to try to do is write them in your own words, go find an example. When you find them in the book, they're usually with examples. But what I wanted to do today was try to do 2 examples with you. So there's a table below this with 2 examples in it, where we get to connect some of these words together so that maybe you can get a better feel for how they work together. One of the difficult things about the terminology in this course is there's so many similarities between each of these vocab words or key terms, how I have them labeled later, that it's easy to mix them up in your head. And so what we're going to try to do is show off the similarities and then show off the differences. There's also some examples below that we will go through in a separate video. So let's get to it. So I'm just going to assume that at this point you have looked through all of these terms on your own and have at least read through them once before we keep going. So let's go to the table. Okay, so the first thing I put here was a little graphic for you to try to show pictorially what it looks like to have a population, a sample, and then the connection between that, a parameter, and a statistic. So if you have read the terms above, you know that population and sample are connected in that they both talk about the group of things you're looking at. In the examples below, one of those groups will be people, and I think that's the easiest way to start thinking about this, is just that there's a population of people, and then there's a small group of those people called the sample. Now, each of those things has with it some way we measure. So again, this class, statistics, is all about trying to answer questions. And a lot of you will be interested in answering questions about people, yourselves, your classmates, people you know, whatever it is. So the way we do that is we have to figure out some way to gather information about those people to answer our question. And the way that we do that is we define this thing called a parameter. That is the way we measure something about the population we're interested in. And so there's terminology here, parameter itself. There's pi, there's mu. We'll talk a little bit more about those later, although they're up there in the key terms. And the idea, again, the overall idea of this is, okay, I've got this big population I want to learn about. I measure something about them, that's the parameter. But guess what? That population is too big usually. It takes too much time or money to try to get information from every single object in there. So again, if you want to think about it in terms of just people, think, I want to know everything about this big group of people, like maybe every adult in the US. It's very difficult to get all of the information you want from every single one of them. So what do? This class is based on this idea of I'm going to learn about the whole, the population, the whole, the population. I'm going to learn about that by studying the small, the sample, right? The small, the sample. And so if I do things correctly, my small group, my sample, should tell me something about my big group. So the sample tells me about the population. How do I measure something about the sample? I compute a statistic. The statistic tells me about the parameter. And so that's the back and forth we're going to do. Back and forth, back and forth. So let's see 2 examples of this. Okay, so the first 2 are called the coin toss and the survey. So I have this broken down into a couple different pieces. One of these, the question of interest, is not a key term, but it's something you're going to start with for all these types of problems. So coin toss, just to set it up for you, I'm going to say I have a coin in front of me. Maybe it's a quarter, whatever type of coin you want. All right, and so my question is this coin fair? And so if you haven't heard that word used for coins before, what we mean by that is if I flip this coin, I expect, if it's fair, it to flip and hit heads 50% of the time, tails 50% of the time. And so some of you might be more comfortable with the probability of heads in a coin flip is 50%. That's what it means to be fair. So my interest is, here's my coin. How do I know if this is a fair coin? What can I do to try to figure that out? Okay, so that's coin toss. The next one is survey. And the question we're trying to ask here is, what's the preferred flavor of ice cream between vanilla, chocolate, and strawberry for DCC students? So if you like having like background stories with these types of things, maybe you're throwing some kind of ice cream social and you need to know what type of ice cream to get, but you only, because of the deal you can only get one flavor. So you're picking between these three, but you don't want to just pick randomly. You want to try to figure out, well, what do DCC students like? Because I should get the flavor that the highest proportion of students will like at the school. I don't want to just pick randomly. But again, might be kind of hard to ask everyone, so that's going to play into these pieces coming later. Okay, so we got the coin toss and the survey. So the next line here, population. So the population is the group of things that you want to know about. So for the coin toss, this is a little bit weird, but in the coin toss, what I want you to do is think to yourself, how could you prove to me, or how could I prove to you that your coin is fair? What would I have to do? And so hopefully you said, well, you have to flip it, because a fair coin is one that 50% of the times it'll get heads. So okay, you flip it one time, it gets heads, just to say. Did that prove anything to you? So hopefully you're saying, no, you can't just flip it once, you've got to flip it more than once. Okay, so I start flipping, and I keep 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 going. When do I stop? And so hopefully you're kind of thinking, maybe you have a number in your head, but let's say you said, you flip it 100 times and I'll be convinced. That is a very interesting thing for you to say, because that is an important piece of this course we're going to really dig into, this when do I stop? But if you wanted to know 100% that your coin was fair, could you really stop at 100 flips? I want you to think about that for a little bit, because the answer is no, you couldn't stop. It doesn't matter how many flips you do, finite number of flips, you'll never be 100% sure. And so you might say, well, come on, Mr. B, what if I'm 99.9% sure? And hey, that's probably good enough to know if you have a fair coin for whatever you're trying to do. Totally agree with that. But the question we're asking here is, how do I 100% know? And that's a totally different animal than being 99% sure or 99.9999% sure. And so in order to know that a coin is truly fair, we would technically have to flip it forever. But we don't have time to do that. So this is again an example of the population is I got to flip it forever, all the coin flips. But I can't do that, so I'm going to need to figure out something else. Okay, switch gears again. For the population for the DCC students, well, I want to know about their ice cream preferences. There's thousands of DCC students. It might be hard or time-consuming or costly to ask them all. So what do? I've only got to ask some of them. And so that idea of I've only got to probe these two populations, not the whole, but just pieces, is this sample down here. Okay, so we've got a question we want to answer. We've got a group of things to look at. One is coin flips, one is people. But once we've got a handle on that, we need to ask ourselves, okay, I have all these people. I need to get something and measure it in order to answer my question. So let's start with the survey. Let's go to this right-hand side. If I want to know the preferences that people have between vanilla, chocolate, and strawberry ice cream, what do? Hopefully it's not too bad to see that you just ask them, right? Just go ask them, what do you prefer? Okay, so I go up to you, you're a DCC student, and I say to you, what's your preference over vanilla, chocolate, and strawberry? And maybe you say chocolate. I say, okay, so I'd write that down, chocolate. And I go to the next student and I ask them, the next one, and the next one, and the next one. And all of a sudden at this point, I've just got a bunch of pieces of data sitting there. Chocolate, chocolate, strawberry, vanilla, chocolate, strawberry. And what do I do with that? So that's a great start, but the point is we need to take that and measure that in some nice, concise way. And that is called the parameter. So the parameter here is the way we measure something about the population. So we got this big group, the population, the parameter measures something. So in this case, we've got many of them. The proportion of all DCC students who prefer vanilla ice cream. That is a parameter because it's some number that would help me answer my question. But actually there's multiple, right? It's the proportion who like chocolate. That's another number that I could get. It's the proportion who like strawberry. That's another number that I could get that would help me answer my question. Now, the same thing goes for coin toss. If you go back to coin toss. So the parameter here, it's got to be something that's a number I can try to measure. So I have the proportion of all of the coin flips that I could ever do with my coin that lands heads. If I knew that number, I would know if it's fair. All done. On the other hand, I could count or I could look at the proportion of times it lands on tails, but if I knew that number, I'd be done. If it's 50%, I'm golden. If it's not fair. So the parameter is this idea you have to think about like, oh, this is some nice number that describes the population and answers my question. So as I've alluded to already, what's the problem? This number is very hard, most of the time impossible for us to actually get. So we use statistics to try to figure out an approximation to it, an idea of it. Okay, so hopefully you're okay with this setup of what we've got going on here. So the next thing is the observational units. Now we're digging in a little bit more to like, okay, on a single level, what are you looking at? A single observational unit. So let's actually make this a unit so it's even more distinct. Okay, so one observational unit. In order to get data, when you're looking at the coin flips, what do you look at? You look at a single coin flip. I flip my coin, I get heads, all done. Observational unit. On the flip side, the survey. I ask all these people, right? But drill down. I want to look at one single case of this. Okay, I asked you, watching this video, what do you like? You said chocolate. Okay, that was data I got from you. That makes you the observational unit. So I got data from the student. That's the observational unit. I got data from the coin flip. That's the observational unit. Awesome. Okay, so then the variable is deeply connected with the observational unit. Once you know what you're looking at, a student or a coin flip, the variable is just a way for you to describe what the data you're going to get from that is. And that's a very important thing to do. So if I'm looking at the student, well, what do I get from the student? I get a flavor, vanilla, chocolate, or strawberry. Because that's the way I would describe the data I get back. Okay, I look at the coin flip. What do I have written down on my piece of paper? Well, the side that you landed on, and that was heads or tails. So we have to be a little careful here. When I'm saying the variable, I mean, in this case, side is the variable, and then flavor is the variable. These other pieces of information I've written down, the heads or tails, the vanilla, chocolate, strawberry, these are all options of the variable. All right, so we got to be a little careful here. This is an option, and this is an option. These are not separate variables. They're options of the variable. All right, so just be a little careful with that. But our variables here are side, as in the side that was flipped over, and then flavor, as in what flavor did the observational unit, aka the student, pick. Okay, so we have this way of setting up all the pieces we're looking at. Now you've set that up, you know what you're going to ask, you know how to record the data, you know all of that. Then you get to the actual sample. So again, remember, the sample is the small, right? The sample is the small group you're looking at. So for example, coin flip, go back up to the coin toss. The population is all the flips you could ever do forever and ever. The sample then is just some finite number of flips you're going to do. So what you could actually do, and so that's why this is bolded here, it's the flips you would actually be able to do, okay? So then that is very similar with this other question here. This other question, the survey, I can't ask all of the population, right? I can't ask everyone. So what do? I look at the smaller group of students that you actually talk to. So if you're having trouble going sample versus population, which is which, the sample is always the group that you actually were working with, whether it's a group of coin flips, a group of people, whatever. So the sample is what you actually are manipulating, you're actually touching, you're actually working with. The population is the big abstract group, all right? So earlier we said population's the big, parameter is the thing we measure about it. Okay, bring that down now. Sample is the small, statistic is the thing we measure about it. So I know there's a bunch of terms on this table and in this section, but you have to start thinking about these things as being together. So sample and statistic are together. Population parameter, they're linked together. Observational unit and variable, these things are linked together. Here, let me make these different colors, I guess. Right, these things are each linked together, and the definitions of them are similar between some of these groupings. So again, population is like the sample, parameter is like the statistic, so very similar. Okay, so in the two scenarios, I'm looking at my coin flips. I actually do maybe 100 of them. So maybe example, I do 100 flips. Okay, so maybe I've done 100 flips. All right, well, what am I going to measure out of that? Well, what am I going to measure? Maybe 52 out of 100 landed on heads. All right, so that my statistic looks like this actual number I can get my hands on. All right, the smaller group of students I actually talk to, maybe as an example, I survey 50 students. Okay, so again, it's just this like actual number of students I'm going to talk to. And 20 out of 50 prefer vanilla. There you go. It's an actual number I get my hands on. 2/5 of the DCC students, my guess, I'm not going to say no there, right? But my guess is 2/5 might prefer vanilla. I know 100% that 2/5 of the 50 people I talk to prefer vanilla, but I don't know that that's true for the whole big group. And we're going to talk about how we use statistics to try to get a guess at that. All right. So one question you might have from this is, oh wait, look at all these different parameters. How come I didn't write a statistic for each of those? Now, that's something I could have done, right? If I was to get this information in the sample, I could definitely do that. But most of the time what we're going to do is we're going to only consider one parameter because we're going to make our question specific enough. So what do I mean by that? Let's look at the coin toss. Is my coin fair? Well, I said it needs to land on heads 50% of the time, right? But couldn't I also just focus on tails? Why did I pick heads? Well, I picked heads because I made a choice. So what we can do for a lot of these types of problems is we can actually just go, you know what? I don't care about this parameter. If I just know the proportion that it lands on heads, I'm done. I know everything about the coin. Similarly, I might have in my, for whatever reason, I might think, I just want to focus on vanilla here. And you don't have to do this, but a lot of the times there'll be multiple options that we'll just focus on one. So maybe we'll say, I'm really just interested in their preference for vanilla because I think that's going to be the highest. So let me just focus my energy on that for right now. So I'm going to cross those out, and then you go. You get your sample, you get your statistic. Of course, if you did the survey, you would have information on the other parameters, and then you can talk about those. But in general, we're going to have one single parameter and one single statistic here. And that's the form we'll usually go with. Okay, 20 minutes, I already went over the time I want to go over. So in the next video, we'll look over the examples. Make sure that as you go through this, you ask me any questions you have. I'm happy to in office hours. We'll have some time during our once per week class meeting, and I'm happy to meet any of you outside of class as well. You just have to email me to set up an appointment.